Now we will start the hands-on of logistic regression. Okay, so we will start with the hands-on on logistic regression. So I think you people have opened the Jupyter notebook and about the data set. So I will show the data set now. The diabetes data set, which I have downloaded from the Kaggle website. Now you can see the data set here. You can see that here is the outcome. Now outcome means since it is the diabetes data set, so this outcome would be whether that person is uh, having the diabetes or not. So that means 1 or 0. So one means outcome one means this particular person having these details will have the diabetes. He is having the diabetes. Now similarly the second person, the second record, the second row. So this particular person he doesn't have diabetes. Okay. So these are the outcomes. That means that particular these persons have diabetes or not. Okay, so similar like this, we have a large number of data available. Okay, for different persons. Now here, what should be the output? Why? Now in every case algorithms, supervised algorithms, we have to split the data set into input and output, X and Y. Now here you can directly see that outcome is specified here. So this outcome is the Y output, and all other columns are inputs. You can see pregnancies, glucose level, blood pressure, skin thickness, insulin level, BMI, then one more diabetes, pedigree function something. One more input is there. Then age. So these are the input columns, vectors. Now this is the corresponding outcome is the corresponding output. So these data we are going to feed into the logistic regression. Okay. Now I'm just closing the data set or let it be there. We will see it later. Now the Jupyter notebook. I'm just calling importing the necessary libraries, pandas, numpy, seaborn, matplotlib, .pyplot. So these are the necessary libraries. I told you Seaborn is for visualization, similar to Matplotlib. Seaborn is a library for visualization. Will give somewhat more elegant diagrams compared to Matplotlib. Okay, so if you want to use Matplotlib only, you can use. But if you use Seaborn, it will give some elegant visualizations. So we will see it later. So I'm importing these libraries. Okay. Okay, now we are calling the diabetes dataset diabetes.csv. So diabetes is equal to pd.read. CSV, diabetes.csv. So we have seen this particular uh, method, or how we will call the data set in our previous session, previous hands-on session. This PD is the pandas dot read CSV. Read CSV is to read the data in CSV format. We have the data in diabetes.csv. Now we are saving the data into the object diabetes. Now the data is there in diabetes. Okay, so instead of this, you can use any variable name, no issue. D or a data, something you can use. I am keeping it as diabetes itself. Okay, that's all. So I am executing this. So the data I have just now shown here has been imported, has been called and saved in diabetes. Now, in order to see that data, I'm just using diabetes.head. You know the use of head. For what purpose we are using head, we have discussed in our previous sessions. Now, it is to display the first five records, first five rows. Okay, so we can see pregnancies, glucose. So the same thing available here. Pregnancies, glucose, blood pressure. So same things you can see here. Column names, skin thickness, insulin, up to outcome. So these are the columns we have in our data set. Okay. Now, if we want to see the complete data set, just type the diabetes. That is enough. It will show the complete data set. You can see it contains 768 rows, 9 columns. 768 rows and 9 columns. So 768. See, from 0, you can see here from 0, 1, 2, 3, 4, up to 767. So that means totally from 0 to 767 means totally, sorry. So that means totally we have 768 data, 768 rows, 9 columns are there. So you can count pregnancies first column, then 2, 3, 4, 5, 6, 7, 8, 9 up to outcome. 9 columns are there. Okay, now just want to see the information. So for that, more information um, using .info will give you more details. These are the different columns 0 to 8, pregnancies, glucose, blood pressure, skin thickness, up to outcome. Outcome is the ninth column, that means having index number 8. Okay, 0 to 8 means 9. So all the column names are there. Corresponding to that, how many non null values are there? See, 768 non null values in all the columns. All the columns are filled. Then corresponding data type, first data type, the first column has integer data type, then again integer, then here floating point is there, BMI. So like that, you can see more details using info. Okay, now you can also use the describe dot describe. You can see describe gives more statistical information about the data set. See, again you will have the pregnancies, glucose, blood pressure, all the columns. And what are the details you are getting here? See, count. The first row means the count. So 768, 768. See, as I have just now shown, see 768 normal value. So here also you can see 768 rows are there. So 768 values will be there, nominal values. Okay, so count is there. Then mean value of each column. Mean value of each column. Mean means the average. Now pregnancies, you can see contains 6, 1, 8, 1, 0. So you have different multiple values here. Now what is the mean of that? Mean means add all the data in the column, then divide by number of data. That is the mean value. So that mean value is 3.8 for the first column. Similarly for the second column. So like that for all the columns. Now standard deviation you can get. The standard deviation you can get. Then that means the statistical value you are getting here using this describe option, describe method, describe function. Okay. Now the minimum value in this particular column. So you can see minimum value would be it is 0. Minimum value is 0. So that means minimum value is 0. That will be shown here 0. Similarly, in all the columns we have zeros, but here the minimum value is 0.078. It's like that. Then this will give you the 25 percentile, not percentage, it is percentile, it is 50 percentile, it is 75 percentile. This is the maximum value. Maximum value means the maximum value this particular column contains. See, you can see in a pregnancies, it is not available here, but it will be there 17 pregnancies. In the pregnancies column, the 17 is the maximum value. Now you can see here pregnancies, what is the maximum value? It will be 17. See, it is 17. 17 is the maximum value. In pregnancies column, 17 is the maximum value. Similarly, in glucose column, what is the maximum value? 199. So, see, in glucose, 199 is the maximum value. So, like that, you will get the maximum values in each column. Now, what are these percentiles? 25 percentile, 50 percentile, 75 percentile. So, 25 percentile means all the values, all the values in this particular column, or the that means 25 percentile of this particular column is 1. So that means 25 percentage of the values in pregnancies column will be less than 1. That is the meaning of percentile. 25 percentage of the data within the pregnancies column will be less than 1. Similarly, here 25 percentile means 99. So that means 25 percentage of the data within the glucose column will be less than 99. That is the meaning of 25 percentile. Similarly, 50 percentile, 75 percentile. See, 75 percentile you see, it is 6 for pregnancies. That means 75 percentage of the data in pregnancies column will be less than 6. Similarly, here 140 is the 75 percentile for glucose. So what is the meaning of that? What do you mean by that? 75 percentage of the data will be less than 140.25 in glucose. That's all. So no need to worry about these things. This is just for your understanding. I am telling you these things are not necessary for the first level understanding. Okay, so I am skipping all these things. This is just to show the statistical information, but this is not necessary. Uh, Not exactly, but for the time being, this is not necessary for this particular hands-on. Okay. And usually, this 75 percentile, 25 percentile, um, values are essential for calculating the interquartile range IQR, interquartile range IQR, interquartile range. Now, based on that IQR only, we will be um, filtering out the outliers. Now, that we are not doing here. So, I'm not discussing about that IQR and eliminating the outlays here. But we will discuss that later. But for the time being, this describe is used to get more information, more statistical information about the data set. You understand that much now. We will discuss this in more detail. Okay. Now, this is enough. We obtained some information. Now, we need to see the null values. Now, these steps are known as exploratory data analysis to get more insights, more details about the data set. That's okay. So that means this getting more information, more statistical information. Okay, so we are getting more clear picture about the nature of the data set. That is exploratory data analysis. So this step also belongs to that. So we are counting the number of normal values. So we have seen this also in our previous hands-on. Diabetes dot is null. Is null is to find out number of null values dot summed. So we have seen this already. Now we can see that in all the nine columns there are no non there are no null values. Okay, that means zero null values. But see, you can see here the minimum value of pregnancy. It is zero. Okay, that is okay. But see here, the skin thickness is zero. Is it possible? Blood pressure is zero. Minimum value. Is it possible? Glucose level. Then this insulin, will it be zero? BMI. But from this information, all are non-null values. Okay, sorry about that. Now see here by seeing the described operation, we can see that some of the columns have some values that are not expected in a real data set. Like insulin cannot be zero, thickness cannot be zero. So that means you see the data set here. See here also insulin is zero here. Here again zero. Here again zero. Here skin thickness is zero. This cannot be possible. So that means these are actually the missing values, but filled with zeros. Okay, some errors happened. Okay, so these values cannot be zero actually, but it is this data set contains zeros. For these values are actually null values. Actually, there should not be any. Actually, there is some value, but they have missed. Okay, they have not incorporated these values here. So these values should be treated as null values. This cannot be zero actually. These are null values. Empty values we can say. These zeros are not actual values. These are some empty values. Now how will you represent empty values? Null values. I told you NaN, NaN. We will discuss it later. So first thing is we need to eliminate these zeros. Then only the operation will be fruitful, we can say. These values cannot be zero. See other values you see, it is 168, 180, 112. See, all the values are more and more than 100. So somewhere around 100 we can say. See, this is 94. This is more than very much more than 100. This is very much more than 100. So all the values will be roughly greater than 100 or roughly greater than 90 insulin values. But see here zero is there. So this zero will affect the entire operation. So what we have to do is we need to eliminate these zeros. Okay, so for that purpose, what we are doing, so you can see the Excel sheet also, the CSV sheet also, CSV data also. See here, there are some values in insulin. See, so many zero values are there. These zero should be eliminated. So I can show you the count of number of zeros. See, so these many data are zeros. 374 zeros are there. So that value is going to affect the entire operation. So we should first of all we should eliminate these zeros from the data set. Okay, so for this domain knowledge is very much essential. You should be able to know the details, input details, and only you can say insulin cannot be zero, skin thickness cannot be zero. For persons who do not have information about these things, may not be able to predict this or understand this. Okay, so the inference is very much essential. The data set inference. So you have to see the each and every details. You should be able to explain by you yourself. What is this thing? Then only you can be a better data scientist. Otherwise, uh, without having much knowledge about these things, if you are feeding these inputs to the machine learning algorithm, you are going to get the less accurate result only. Okay, so first thing will be eliminating these zeros. But see, pregnancy, you see the column pregnancy. So this pregnancy can be zero, no issue. So that means all the zeros cannot be eliminated. Now see outcome also you see zeros are there in the outcome. That is the real zero that cannot be eliminated. Okay, so can you or can we eliminate the entire insulin column? That is possible because we have done in the previous class, we have eliminated some of the columns. So, in that way, can we eliminate this insulin column? That is also not possible because insulin is very much essential in order to predict or classify the diabetics. This is an essential data, important feature. So insulin column cannot be eliminated also. So the only thing is that is possible is you fill these zeros with some um, mean values of all the other insulin data, data present in the insulin column. Take the average of or mean value of all the other uh, insulin and fill up these zeros with the mean value of the insulin values in the insulin column. That is only possibility. Okay, instead of mean you can use mode also. That is also possible. But I am using mean only. Okay. So for that purpose, what I am doing is, first of all, by seeing the null values, there are no null values. But see, you have to see the describe also or the data set also. So in the data set, you can see there are some what to say uh, incorrect values in the insulin column as well as in the skin thickness column. Okay, so what I am doing is, so I will first of all I will eliminate these pregnancies and this outcome column because these columns contain zeros, real zeros. So we cannot change this real zero. This is the actual outcome. Similarly, we cannot change this pregnancy. This is actual. So first of all, what I am doing is I am just deleting these pregnancies and the outcome from the data set. Then what I will do is I will fill these insulin zero values with the mean of the insulin column. Similarly, skin thickness uh, mean will be taken and the zeros will be replaced with the mean value of the skin thickness column. Okay, so that is the thing I am going to do now. Any doubt up to this? Okay. So that means, see, here I am just dropping pregnancies and outcome column. For what purpose? Just to fill up these values, these zero values with the mean of the corresponding column. Now these zeros, the zeros under insulin will be replaced with the mean of the values in the insulin column. Similarly, the zeros at skin thickness will be replaced with the mean of the values in the skin thickness column only. Okay, similarly in all other columns. If there are some zeros, those zeros will be replaced with mean of the values of that column. Because blood pressure also mean is okay. Glucose also mean can be okay. Mean is okay. So wherever you require mode, you can use mode there. Wherever you require mean, you can use mean there. It's up to you. Okay, so I'm just deleting the pregnancy column and outcome column. Then axis is equal to 1. It is to say that these are the column labels or column names. Axis is equal to 0 is by default. This is by default, no need to give this. So this means that row operation. So by default, this is row operation. By default, that the drop operation is row operation only. So in order to make it column wise, we are changing it axis is equal to 1. By default, it is axis is equal to 0. So we have seen these things also in our previous session. So I am just eliminating that pregnancies and outcome column. Okay, now just a second. Okay, I'm just doing a instead of x I will be using instead of x I will be using this name, this subject. Okay, so I am just taking this new data set with the pregnancies outcome eliminated into diabetes DF. Okay, now what is the diabetes DF contains? See, the same data set with the no diabetes, sorry, same data set with the no pregnancies and outcome columns available. See, outcome column was there actually. See, after age, there was outcome column. That is not there now. After age, nothing is there. Similarly, before, I think before glucose, we had pregnancies column. Yes, before glucose, we had pregnancy column. That column is also we have deleted. Okay, so now we have the data set in diabetes underscore TF. Okay, so what is the thing we need to do now? We need to replace these zeros by the mean values of the corresponding column. So for that, we need to use this symbol imputer. Okay, so Symbol imputer. So imputing means replace, actually we will replace the values. So the symbol imputer means we will replace the values with some other values. Okay, so it replaces actually np dot nan value. Nan values will be replaced, but see here there are no nan values. There are no nan values. Nan values means the empty values, but here in our data set empty values are replaced with zeros. So what we have to do, we have to first of all replace these zeros with nan values. So for that I am using the diabetes df dot to replace zeros with the np dot nan. Then in place is equal to true. That means we are altering the actual data set. Okay. So now when you execute this, see, just a second. I will restart it. Um, or restart and clear output. Something has happened, so I will restart it. Okay, I will execute one by one. Once again. So this will happen occasionally. So at that time, you please restart the kernel. So you go to this kernel. You can restart and clear output or restart and run mode. Both the options you can give. Uh, see, not this one. Here, see, all the zero values. See, we had zeros here, here also. So similarly, in other places also we have zeros. So those zeros are replaced by nan, not a number. Actually, these are the null values, empty values. Okay, so wherever we had zeros, all the zeros were replaced with nan. Okay, so here see nan, nan. Okay, now we can use. Now again, you see, again you see the info. Sorry, easnal load sum. See, glucose has 5 null values. Blood pressure has 35 null values. Skin thickness 227 null values. Insulin 374 null values. See, these are the null values. Nan values are actually null values. So these were actually null values, but during the dataset collection, they have replaced these null values with zeros. What can we do? We cannot do anything. So what we have done here is, by identifying these zeros are not actual zeros, what we have done is we assume these are actually null values, and we have replaced these zeros with the nan, not a number. So not a number means actual uh, nan only. Nan means not a number. So this is the actual representation for an empty cell, empty value, nan. Okay, so here np dot nan means this nan is available in numpy. Nan is available in numpy, so that is why np dot nan. See that np we have already called here, numpy. Okay, so we are intentionally adding that np here. Usually, whenever we call some data set, that nan value will be there. But here in this case, this is actually a difficult case. Actually, when we see the info for the first time, or when we see the null values for the first time, see, there were no null values. Okay, so this is actually quite misleading. But when we see the actual data set, see more information, see like this describe and all, you can see some zero values. unwanted zero value. So by seeing that, you can judge by yourself that these are actual null values, but falsely replaced by zero. Okay, so that thing we are going to eliminate now. So we have replaced those zeros by non values. Now we have the data set now here. Now when we see the is null, you can see these many uh, null values are there. Now what we are going to do is we are going to replace those null values or non values by using imputing function. So, so the symbol imputer, it replaces np.nan, that means missing values, with the mean, median, or mode. We can specify anyone. It can be the zeros. Sorry, nan values can be replaced with the mean, or median, or mode. It's up to you. Okay. Now we are just calling that symbol imputer from the sklearn. From sklearn.impute, import symbol imputer. Now we are taking that symbol imputer into an object. See, symbol imputer of strategy is equal to mean. Strategy is equal to mean. So this can be median or mode, no issue, depending upon the data also. Now, if you find using mean is suitable, you use that mean. If you find using the mode is suitable, then you go for mode or median, no issue. Okay, so here I am using main. Then the new array I am forming is diabetes array, which is imputed dot fit transform of this. Uh, what is the data? Okay, diabetes DF. We have the actual data in diabetes DF. Okay, so diabetes. I am creating a new data set in diabetes array, which contains imputed data set. So this is the actual data set we have in diabetes DF. We have fit transform. Fit transform actually applies this imputer to the dataset. Transform the dataset by applying this imputing function, which is there in the imputer. Now the diabetes array contains the new dataset. So let us see the dataset. Oh, this is not executed. Okay, I will execute this. Then I will execute this one. See, but the problem here is this will be a numpy array. Now it is very difficult to visualize this, so I am just transforming this numpy array into data frame. See, diabetes df new is equal to pd.data frame. I am transforming this diabetes array into a data frame using this function pd.data frame. So we have seen this already. What is the input to be passed? Diabetes array, that means this one. This is the numpy array. Then column name should be the columns of this particular data set. When you execute that and when you see that, see, now see here you can see this is, we cannot interpret this. This is very difficult to, it is very difficult to interpret this particular numpy array. So we are transforming that numpy array into a new data frame, diabetes df new. That's all. Now you can see here, we can see everything in the data frame. Now see, insulin values 155. It was previously 0. It was previously 0. We have replaced it by nan. Now these nan values are replaced with mean of the column of the insulin. Okay. So here nan is there. Here also nan is there. Here also nan is there. So some like that we have nan in different places. All those nans are replaced by 155.554. See here, 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 see here. So wherever we had zeros in the insulin column, all those zeros uh, have been replaced by these mean values using this symbol imputer function. Okay, please go to, you please refer some documents to see more information about this imputer operation. Okay, so like that in skin thickness also we had some zeros. See, now we have no zeros here. See, in skin thickness we had zeros at third column. That means third row. That means second index row. See, we had 9 here. See that 9 replaced by this 29.15. Okay, see 29.15. Similarly, here also 29.15. So like that, wherever we had zeros, uh, we had replaced those zeros by mean values of that particular column. Okay. Now we have the data set, processed data set with all the null values replaced by mean of the corresponding column values. Okay, so we can we use this as input, because see, you can see this particular data set doesn't contains outcome, that is output. So can we use this one straight away as the input? If you want, you can use, no issue. But see, here we have dropped one column pregnancy. Now why we have dropped that pregnancy and outcome? Because these columns had zeros, actual zeros. When you replace zeros using imputing, these zeros will also be replaced. These zeros will also get replaced, actual zeros. So that is the reason why we have eliminated or dropped these two columns priorly before imputing. Okay, but see, pregnancy actually has an effect on the diabetes. Okay, so that is the reason why we need to incorporate this pregnancy into the as the input, as the important feature. Okay, outcome we do not want to give us input, because uh, outcome is the output. Okay, so this pregnancy also we need to add to the imputed data set. How we will add? See, using concatenation. See, the diabetes, we have the new array here. We have the new data frame here. What array? It is data frame diabetes df new. So we have to concatenate to that new data frame the eliminated column pregnancies which we had in diabetes. That means here, actual input data set diabetes. See here, this pregnancy we eliminated. Now we are going to add that pregnancy again to the imputed data sets. See here, imputed data set is available in imputed converted data set is available in diabetes DF new. Okay, so we are going to concatenate the diabetes pregnancies column available in diabetes dataset. Concatenate, pd dot concatenation. So we have seen this concatenation operation into and we are producing a new one. Not a new, it is new one. Okay, so we are getting a new data frame diabetes df new one. Okay, Now we will just see the data frame. Each time you try to give different names so that there won't be any confusion in the future. So you can see that pregnancy column we have concatenated at the last. Concatenation means at the last only, as the last column. Okay, that column order is not an issue, not a problem. So now we have the actual data set ready. So this contains input columns only. Output column is outcome, so that we are not concatenating here because that we are going to keep as an output. See, output we have taken into Y. Output we have taken into Y. So that is there in diabetes only. Diabetes data frame output, which we had eliminated priorly before imputing. So that we are taking into Y. Okay, so see, we have Y in, we have outcome in Y. If you want, you can see that Y also by just typing Y. I am just keeping small letter Y here because usually for Y it should be a small letter. There is no particular rule like that, but it is the convention. See, the Y contains outcome values. See, 1, 0, 1, 0, 1. So like that. That means these outcome values. See, one outcome, 1, 0, 1. So like that. All the outcome values will be available in Y. Okay, all the outcome values are available in Y. Okay, where is the X values? The input value, X values will be the data in this diabetes DF new one. Okay, now if you want to delete some data from here, some column from here, you can do that because we have seen that thing already in our previous hands-on. Multiple linear session, we have seen how to eliminate the unwanted columns. So that process also you can do here. Okay, by just seeing the correlation, by plotting the heat map, we can do that thing here also. The same process we can do here also. That we are not doing here. Rather, I am just taking the entire this as the input X. Okay, so I will take this into X. So just a second. Uh, X is equal to this one. I am moving the data in this particular data frame into X. Now, if you want to visualize that X, you can visualize like this. If you want to see the first five value, this is the method. See first five values. Okay, now we have X value and Y value. Y is usually small. That is the convention, but there is no stringent rule like that. You can give capital Y also, no issue. But usually this is small y and the capital X. Okay, so we have X and Y. Now we want to do train test split. Now same procedure, train test split. Now for that you import the train test split which is available in sklearn dot model selection. Now, what is the speciality in showing like this? See, from sklearn dot model selection, but here, see, you can see that here we have imported the entire pandas. See, we have imported the entire pandas library. Here we have imported the entire NumPy library. But here we are importing only the necessary code, the necessary function in this way. So that is from sklearn dot model selection. import train test split. That's it. Okay, so now we have imported this train test split. Now what we have to do, to that function give x and y, x and y, then a test size you keep 20 percentage, that means zero point 0.2, then random state you give any number, no issue. I'm giving 4 or 44. What is the need for this random state? I explained in the previous session. Now, whenever you give this 44 again and again, you will have the same splitting. Otherwise, without this random state, if you execute this, okay, that is no okay, no issue. But the problem is when you execute it again, it will split the data set in a different way, in a random way. Okay, so this is okay, no issue with this. But the problem is when you execute this again, this will do the splitting in a different way. The order it will take will be different. I explained the same thing in the previous session. Now, in order to keep the same order, what I am doing is I am just giving a seed point, seed. That is the random state 44. So, whenever I use this random state as 44, I will have the same splitting, same order of splitting. Okay, so I will split that here. Test size I have selected is zero point 0.2, that means 20 percentage. See, if you want to see the train and test, you can easily visualize. First of all, I will show the train X train. Now you can see the training data set. See, training data set. Okay, how many data set? How many data we had? 768 rows we had. Now, see, training set contains 80 percentage. 80 percentage. That means it comes 614 rows. 80 percentage of 748 or something. Yes, 768. 80 percentage of 768 you calculate, it will come around this 614. So these many data, these many rows present in X train. Similarly, you uh, see the X test, the remaining 20 percentage. So this contains X train contains 80 percentage. The remaining 20 percentage will be available in X test. Now you can visualize that too, but I am not doing that here. Now see the order in which the rows has been taken. See, first it has taken the 626th row, then it has taken the 137th row. So there is a randomness here. Okay, so that randomness will be saved for the next time using this random state. So whenever you use this 44 again, you will have the same selection. For that purpose only, you are keeping this random state as some value. Now, whenever you use this random state again as 44, you will have the same splitting. That means in this particular order. Okay, if I am not using this splitting or if I am not using this random state, what will happen? You can see it directly here. I am splitting it. See, this is the output I am getting as extreme. See, 480 is the first line, 56 is second line. Now I am executing this again. See, executing this again, and I am executing this again. See, this time I have selected different row. So there is a randomness here. But when I am setting a random state here, like this, and I am executing this, see, see now it has selected, see, 626, 137. See, the same thing we have already selected. Now see, I am executing this again by keeping the 44. See, this time also it has selected the same order. Now, for this to happen, we have to keep the random state, a seed point. Okay, now we have taken the, we have splitted the data set into training and testing sets. So similarly, you can see the test set also. Now, what is next step? We want to import the logistic regression function, then fit it. That's it. Fitting that function with the X train and Y train. So this thing we have already seen in our linear regression. The same thing. Now, first of all, I am calling the logistic regression from sklearn dot linear model, importing logistic regression. I am taking that into an object logitreg. Now I am fitting that logistic regression function. I am fitting that logistic regression function which is available in this logitreg to the training data, X train and Y train. Okay, that's all. Now see, the logistic function has been fitted with the training data. That means training has happened now. Training is over. That means our model has created now. That S-shaped curve has been created now. So you can see here, logistic regression function has been executed or created. Now the next thing is we need to have the testing. Now for that we need to give X test. Now for that, first of all, you predict the, see, we have the logistic regression function is function in logitreg. See here we have the logistic regression function in logitreg. Using that function, you predict for the X test. So this operation I have already, the operation I have already explained in the previous hands-on session for linear regression. The same operation, the entire framework I have explained. Okay. So in the same fashion, you do the testing with the test data. Now the predicted output will be available in Y hat. Now see the predictions. Sorry, this I will execute and then I will display. See the predictions. These are the predicted output or classified outputs. See, for X test, the corresponding predicted output is Y hat. That means these outputs. Now see the X test here. See the X test which we have already obtained. Then we can compare. See the X test. See. Okay, so these are the test data. These are the test data. Okay, corresponding to this test input data, the corresponding outcome, predicted outcome is this one. Corresponding predicted output is this one, outcome. Because this is what is intended actually. It should be, that means this particular, the first data, the first row belongs to class 0 or class 1. The second row belongs to class 0 or class 1. That means the prediction output, classified output. See, here I am using predicted and prediction and classification interchangeably. Both are same here. Okay, so for this particular, the first row, this is the corresponding output. So like that. Okay, now you can see the white test, corresponding white test. That means the actual output corresponding to X test is available in Y test. This is Y hat, not Y test. Now see the Y test, Y test. Y test is not defined. See, just a second. Yes, Y test is Y should be capital. I have used capital. Okay, no issue. Y. Okay, Y test. Y test. See Y test. Actually, the actual output is 0. Predicted is 0. No issue. Predicted is available in Y hat. It is 0, actually is 0. Okay. Then next is 1. Predicted is 1, actually is 1. Okay, no issue. Again, you see different values. See, here it is 0, actually is 0. So there is no issue here. So whatever we have seen till now, see these four data we have seen till now are correctly classified. See, we had 0 1 1 0 1. See, here also 0 1 1 0 1 correctly classified. Okay, so this is the comparison between Y test and Y hat. This is what is required, isn't it? Now we have done the same thing in the linear regression also. Now we have the actual output and the predicted output. Now, what is the next thing we need to see whether the performance parameters are okay for us. Now, we need to get the accuracy, precision, recall, everything. So, classification report we need to get. Then only we can say we have obtained a good model or not. Okay, so by seeing only the first values, we cannot say that this is a good model. By seeing only the first four values, we cannot say that this is the good model. But we need to see the classification report, the performance parameters. So for that, as I told you, here in the performance parameters, see here I have shown the confusion matrix. Here also I have shown the here. Okay, I deleted that. Anyway, I have shown the confusion matrix, and I have explained what are the different accuracy, prediction, sorry, precision and recall, specificity, F1 score, AUC, everything I have explained using equations. Now, those things I am going to implement here. So, first of all, I will have the confusion matrix of Y test and Y hat. That means this Y hat and Y test. Okay, the performance parameters. Now, when you see this confusion matrix function is available in sklearn dot matrix. From sklearn dot matrix import confusion matrix. Now you use that confusion matrix on Y test and Y hat. See, this is the confusion matrix. Now you can visualize this using heat map, which is available in SNS. That's why I told you this Seaborn SNS will give you elegant picture representation that we can visualize here, which is not available in Matplotlib. So that is why we have imported Seaborn. That's all. So let us see what is that confusion matrix here. See, this is the actual confusion matrix. Now, with the help of Seaborn, I am just printing the or displaying the confusion matrix here. Now, just see the confusion matrix. I will open that Excel sheet once again for better explanation. See, this is the confusion matrix. This one we have explained already. This one we have already explained. So here is the confusion matrix. Okay, so the same thing we are obtaining here. So first one is true positive. So there are 87 true positives. First value is true positive. 87 true positives. Then a false positive. 3 false positives, then false negatives, 26 false negatives, then true negative, 38 true negatives. Okay, so this is the confusion matrix. Now, how we can obtain the accuracy using the equation? How we can obtain the accuracy using the equation? What is the equation? Accuracy is equal to Tp plus Tn divided by Tp plus Tn plus Fp plus Fn. That's all. Tp plus Tn, sorry, Tp plus Tn. Here you can see, or here you can see directly. Tp plus Tn divided by Tp plus Tn plus Fp plus Fn. You directly calculate in the calculator. You will get the accuracy. Or there is another way. Um, you have a this one simple method. See, classification report is available. A separate function is available. This will give you the accuracy directly without having calculating, without the need for calculating it manually. You can have the accuracy directly. There are other methods also, but this is simple compared to the other methods. See, this is available in sklearn.metrics import classification report. Instead of classification, instead of uh, the confusion matrix, we have classification report. It is actually giving the report. Now you print that classification report, print the classification report for y test versus y hat. That means the same thing. Here also you have given y test, y hat. Same thing you input to classification report. Then you can see a nice report like this. So here you can see precision, recall, F1 score. Then support also is there that we are not going to explain here. Similarly, this micro average, weighted average, so these things are also we are not going to explain. But you see, precision is available, recall is available, F1 score is available. Now the accuracy also is available, which is, see, accuracy for one is 0.93. Sorry, precision for one is 0.93, 0.40 is 0.77. Or if you are confusing with this, you use the equation directly. You will get the accuracy. Okay, that is available here. Accuracy is equal to Tp plus Tn divided by Tp plus Tn plus Fp plus Fn. That is okay. You will get the accuracy. Now we can see the accuracy here. Find the accuracy. What is Tp? Tp is here. Tp is 87 plus 38 divided by 87 plus 38 equal to 125. So 125 divided by Tp plus Tn plus Fp plus Fn. That means 125 plus 26 plus 3. 26 plus 3. 154. So 125 divided by 154. 81.11. See, 0.81 is the accuracy. 81.11 is the actual accuracy. It is shown as 0.81. Okay, if you are not Okay, with this particular classification report, you can use the equation directly. Okay. Now, similarly, you can find precision, recall, everything, F1 score. That's it. Now, see, accuracy 0.81 is somewhat okay for us. So, with this, we are going to have the prediction. Prediction. Now, for prediction, what input I should give? How to have the prediction? Logistic, which is the logistic regression we have already done. See, logistic contains the implemented logistic regression here. See here, see logistic dot to predict in order to predict the output. Okay, so the same thing we are going to do. Logistic dot to predict of a new input. New input means input should be like this. Like this means see like this. So these many data points should be there. See how many should be there? One, two, three, four, five, six, seven, eight. Eight data should be there. The first one belongs to glucose, second one belongs to blood pressure, third one belongs to skin thickness. Similarly, that up to pregnancies. So all the input should be given. So here I am giving a test input. See, this is the input I am giving. This is for glucose. This is for the second one. So like that I am giving some input. Now see the corresponding output. See, it belongs to class 0. It belongs to class 0. Okay, so this is how we will have the prediction or classification in logistic regression. Similarly, if you try with a new input, so instead of this I am giving, instead of this one I am giving 0 input and changing. Now how the prediction? See, it is giving the same prediction. Okay, you use exact input. So this is actually for explanation purpose. This is not the correct input. If you give the correct input, you will get the actual one. I don't have any correct input now. That is why it is giving 0 again and again. Okay. Okay, anyway, so this is how we will have the logistic regression model. Now, what we can do is similar to the previous class, as I explained in the previous class, you can save this model. Uh, you can save this model and you can take out and you deploy in any of the cloud available. Then get the corresponding URL. You can give that URL to anybody to have the diabetes prediction. Let that person enter the corresponding input and get the prediction. That's all. That means this logistic regression function, if this much, if this much performance metric is okay for you, if this performance is okay for you, what you can do is you can save this model to somewhere and you can take that model outside and you can deploy it to cloud, get the corresponding URL, then you can sell that URL or you can give that URL to somebody and that person can enter the corresponding details like you have to give the option for him to enter the corresponding details like when you execute that URL, it should ask for these inputs. What is your glucose level? What is your blood pressure? What is your skin thickness? What is your insulin levels? Like that, it should ask for these details. Now, when the person enters these details, it should automatically give the corresponding class. A class 0 means that particular person is having no diabetes. So, like that. Okay, now we can have the one more performance metric that is the ROC AUC. AUC ROC score. Now it is 0.78. So that is okay. I told you while explaining the AUC ROC, here it should be always greater than zero point 0.5, or it should be not zero point 0.5. Here 0.5 is the least value actually, but something greater than 0.75 is okay. Something AUC greater than 0.75 is okay, acceptable. Now we are getting 0.78. That means okay. Okay, so 0.5 is the minimum value above which it should be actually 1. The ideal value should be 1, but that is not possible in many of the cases. But something greater than 0.75 is acceptable. 0.75 is acceptable. We are getting 0.78, so we are getting a good model as per the ROC performance metric. Okay, so this is all about the logistic regression.